Okay, so we spent some time in the past doing binary conversion, and it's really geared for this part of the class. We're going to focus on IPv4 subnetting, only because still you have companies and networks that mostly use IPv4. And in your certification, they will likely ask some questions related to it. Network Plus, not in depth, but if you are going for CCNA or other certification, you will need to know how to subnet. So subnetting is a way that we can take an IP address or a group of IP address and we can subdivide it so that way it would allow us to expand our locations. So for example, I might start with a small business and over time I grew exponentially. This allows us to be able to use the existing configuration and be able to apply new or subnets to our environment without having to change everything. So you do see this with a lot of the larger scale business. So let's say that we are running out of IP address, we can implement subnet to be able to expand, right? Or have more devices added to the network. So a way that we can subnet is to mask the bit in your subnets, right? Like the 255, 255.0.0, that what you see. So depending on the type of address and the class. And before we get into the steps, let's go through and answer some questions. So the first question, it asks you the purpose and the benefits of subnetting. What is it, right? So the purpose of subnet is to take your current IP address range, and we want to divide it up into multiple groups or ranges of other IP addresses that will allow us to have separate subnetworks within. So for example, I might be able to expand into other geolocations this way, where I can route, right, into still my network, but we can separate the network this way. And in security, this could be of importance because that allows you to have segmentation and segregation of different private part of your network. Now, the subnets can be divided, like I mentioned, into different locations, like your branches. Let's say you have a corporate office in San Francisco and you are expanding into Los Angeles or even San Diego. That allows us to add additional subnets to our network, and we would be able to manipulate the subnet mask to be able to use these IP addresses. It also allows us to be able to control our network traffic. So this will help us reduce some bandwidth use because it's not funneling back directly into your original routers and networks. So what you can do is you can subdivide that right into other routers. So that way they can pick up the traffic and be able to route it to still other departments or other areas. Now, you also see subnet being used for virtual local area networks. You okay?
Yeah, yeah.
And that would help us with keeping our network information flow in a certain direction, such as we can set up different VLANs. And VLANs can be used in a way where I can have multiple VLAN on the switch and be able to implement each VLAN for different departments like engineering, manufacturing, and other areas. So this is a way that we can control how data is flowing into our network or throughout our networks. And when you implement things like this, you would use a layer 4 switch. Like I mentioned, you can add VLANs to it. You might have data center where you have more servers and more devices, appliances, security appliances, and you might need a new IP address to be able to expand your infrastructure. So subnet is a way that we can take existing IP address and be able to scale to a larger or a different areas of our network. So today, we are gonna look at how we would be able to see things from a binary level and also to be able to calculate the number of systems that needs IP addresses or the number of hosts, right, or systems, or even the number of subnets that we can implement in our existing environment. Okay, so before we go through number 2, I want to point you to your notes, right? So I tried to write down the steps on how you would approach something like this if you're given an IP address. So in this example, you would start with asking a few questions. First, how many subnets will you need for your network, right? Sometimes right now we might have only one network, right, using the IP address or that range of IP. And what we want to do is we want to calculate the number of additional subnets that we want to add using the IP address. So you would start with asking how many subnets do you need? And that's going to help you determine the value is we are going to find the n exponent from a base 2. Why a base 2 is because the system understands binary, right? And it uses 0 and 1. So your mask bits basically is the value of n. And what you're doing is you are using some bits in your host, right? In your host octet to be able to implement additional subnets. So for example, this IP address 10.0.0.0, right? This is a network IP address and it is a class A. By a default class A, you have 255.0.0.0. So we know that the 255 represents the network ID and the rest are the host ID. Now, if we want to subnet this IP address, basically we're going to borrow some bits into the next octet. It's kind of like leaning into the next octet, similar to what you see that you have houses built in a city. And what you want is that city may be running out of space. We want to be able to expand or borrow some land into the next city by using a different zip code that's very close to ours. So we're basically masking the bit on the next octet to be able to have more IP addresses. So if you are looking at the subnet mask, 255 represents all the ones being on for that octet. And then the 0 would be all the 0 that's followed subsequently on that line. Now, how do I know how many bits that I'm going to borrow into the next octet is that you need to ask yourself, how many subnets do you need, right? So if I need 4 subnets, I would say, what is the exponent when I'm having a base 2? 2 to the n needs to give me, it needs to yield 4. So 2 times 1 is 2, 2 times 2 is 4. So we would say that the nth value here in this case would be 2 to the second power. That's going to give us 4 subnet. Now, in the case that if you need more subnets than what you have as an exponent when you calculate. So for example, I need 10 subnets, right, for my network. But if I do the calculation, 2 to the third power gives me only 8. So I'm short, right? So that means that I have to raise it to the 4th power. So 2 to the 4th power gives you 16 networks. That means that I can have more. So it's okay if you have an exponent that's going to give you more subnets. And if you have 16 subnets and in the calculation, you can use 10 out of the 16, okay? So in such case, you just have to determine how many subnets do you need, and that's gonna give us the mask bit. So in this case, our mask bit is gonna be 2. That means that we're gonna borrow 2 into the next octet, okay? And so when you plug this value into your programmer calculator in binary and convert it to decimal, you will get 192. And that's how we're able to derive the subnet mask for the mask bit, okay? All right. So we would start with asking ourselves, how many subnets do we need? So let's do the exercise together so you can have a better understanding. Number 2. So we're going to use the table so you have a visual understanding of it. But let's say that I'm given 172.14.0.0. You know that this is a network IP. This is what your router used to bring the traffic into the network, right? So the router is a transit system. It basically takes the traffic and bring it to your network area. And then the switch is going to take it over and determine which host is receiving the traffic. So it might be using, right, your network address, okay? And network address is not usable for a device or a system, such as we know that as a host. So if we're given this IP address 172.14.0.0, and we want to be able to create 8 subnets out of it, okay? So we know that we have to yield 8 subnets. And so first you take that IP address and you ask yourself, what is the default subnet mask for the class 4 IP, right? So we know that this is a class B by looking at the first octet, the 172, right here, right? And so I would write down the default subnet mask, which is 255.255.0.0. And from there, I would be able to identify which octet represents the network and which octets represents the host. So in subnetting, we simply borrow into the next host octet, the one that's highlighted, okay? So the 255 stays the same. We're just going to mask the bits in the host octet. So if I convert this, the default subnet mask into binary, I would have 255, right, as ones there. And the next decimal 255, that's going to be all ones. And then the rest are going to be 0. But I'm going to borrow the first 3 bits. It's always going to be the first few bits, sometimes more than a few, that you're going to borrow. You don't borrow from the back, you borrow from the front, right? So I'm going to need 3 bits. Why 3 bits? Because if you're looking at the question, it tells you that you need 8 subnets. And you ask yourself, if I require 8, what is the nth value? 2 to the n is equal to 8, right? And algebraically, when we solve this, we can use the natural log, but you can simply think about 2 times what, right? 2 times 2 is 4, 2 times 3, 2 times 2 times 2, 2 to the 3rd power is going to give you 8, right? So you are going to solve for the exponent here, and that exponent is going to give you the mask bits here, right, in your subnet mask. So I know that I need 3 borrow bits because I need to yield 8 subnets. And if you miss it when at the beginning, you can have more in your calculation and you can use up to that amount. So if I need 10 subnets, I can have 2 to the 4th power, which gives me 16, but I'm only going to use 10 out of 16, and that's okay. Okay? So In this case, we're gonna borrow 3 bits because the third power is gonna give us 8 subnets. So when I converted this into a binary, I rewrite the subnet mask. So the 255 are all ones, they stay the same, right? The next 255 are all ones, they also stay the same for the first 2 octet for the subnet mask. But I'm gonna change the first 30 from the original subnet mask, the default subnet mask, to the 3 ones because we're borrowing 3 bits into the host octet. And if you count up the ones, you get 19 ones because there's 8 here in the front, right? You've got 8 ones right here. And then the next 8 ones, that's going to give you 16 ones, and then added a 3 that we're going to borrow, which gives you CIDR 19. Okay? So the new subnet mask in binary for the 8 subnets that we're going to create, we're going to have the CIDR 19, which use a different subnet mask now. Okay? Any question? So as I showed in the prior 2 lines, we're going to borrow 3 bits. So 2 to the third power is going to give you 8 subnets. That's what the question 2 required. Now on the next step, you are going to take the CIDR and you're going to implement it into the solution where you want to calculate how many systems or hosts you can have per subnet. Okay. And we want to calculate this so that when we would have enough computers, devices that will be connecting for each of the subnet that we are creating. So do you follow me so far with the 19? Okay, so we have 19 ones, right? Because there's a 3 that we're going to borrow based on the calculation. So now we want to calculate the number of hosts, which is the next step, okay? The second question is how many computers will be connecting in each subnet? So we're going to use 2 to the 32 power. Why the 32 power? Because there are 32 bits in IPv4 address, okay? So it's always going to be 32 for IPv4, right? So that's the total number of IP addresses for IPv4. And we're going to subtract it by 2 to the 19th power because this is now the new CIDR or the new subnet mask that we're going to have implemented for our 8 subnets, okay? So you're going to subtract 2 to the 19th power. And I would do the calculation here, right? So if you know the algebraic way we solve this, you simply take the exponent, you subtract because the base is the same, right? But you need to subtract 2. Why 2? Because you know that the network IP, the .0, is not usable. You cannot assign it to your host. And you cannot use the N broadcast address, which is the .255. So I cannot use 172.14.0.0. That's off the list for any computer, any appliances, any devices that needs to be having an IP address, right? I need to make sure that I cannot assign the .255 because the .255 at the end. So 172.14.0.0. So I'll put that here, a note, right? No, right? Subtract 2 because 174.14.0.0 cannot be used, right? Or 170 I typed 174, sorry. 172.14.0.255 cannot be used. Okay, so that's why the start, which is the .0, and the end, which is the .255, cannot be assigned to a host. So your host is going to be equal to the total number of IP address for IPv4, which is 2 to the 32 power. You're going to subtract it by 2 to the 19th power because this is going to be your CIDR or your subnet mask for your 8 subnets. And you're going to also subtract the 2 because the beginning address and the ending address is not assignable to, it cannot be used in that range. And so if I take the exponent 32 and I subtract the 19, I should get 2 to the 13th power because the base is the same. You take the exponent and you subtract it, you get 13 here. And then I subtract the 2 on the outside here, and it would yield 8,190 hosts per subnet. Okay. So the step is that you need to determine the number of bits that you're going to borrow or mask to identify your CIDR, okay, your mask bits. Then you're going to take that and implement it into the equation, and the 32 is always going to be the same for IPv4. Like I said, you subtract it, find the difference minus an additional 2, and you get your number of hosts. Now, then we are going to take the IP address, and this is what it looks like in binary. You can simply use your programmer calculator to convert 172 to binary, and then 14 to binary, and the 0 are all 0. Okay? The reason why I wrote it out this way is because I want you to see the changes in binary as we progress. Right? You don't have to convert it to binary, but if it's easier for you to see what it looks like in the variation of the bit, it's probably easier to look at it from a binary level. Any question?
How do you get the 3 bits?
Because I need 8 subnets, and 2 to the 3rd power gives me 8. So if you need 16, it's 2 to the 4th power than you borrow. So the more networks you need, the more subnets you need, the higher the exponent value, right? The higher is the end here. Okay, any questions so far? Then what we will do next is we want to look at those 3 borrow bits, the green highlight, right? I asked myself, how many combination of 0 and 1s that you can do? And it's exactly the exponent that you use for the mask bits, which is yielding your subnet. So you would have 8 variations, right, in how you can switch up the 0 and the 1s. So the first variation is they're all 0. The second variation is 0, 0, 1. And if you're looking at the pattern for the combination, you notice that the 1 is simply moving from right to left, right? So you have 0, 0, 0, 1, and then 0, 1, 0, and then we keep adding another 1. So as we go, 0, 1, 0, 0, 1, 1, until we get all 1s. Okay? So there are 8 variations that we can switch up these mask bits for each of your subnet. So this represents these mask bits for each of the subnets. Okay. Questions? So now if you need more, like let's say you need 16 subnets, you would look at those. There should be 16 variation on how you borrow the 4 bits. Okay. So let's go through the table together. So I kept the first octet in decimal. I wanted to, and you can keep the second octet in binary or decimal. That's up to you. So the 172, this binary represents the 14. Okay. Now, I care about the third octet in binary because I want you to see the transition on how we implement the variation, the combination that we talked about up there in the first 3 bits in this case. Okay. So why this third octet? Because this is the host ID. Okay. The third octet represents the host part of the IP address, and we are borrowing into it. So we're going to use the first 3 bits from that octet. So the original IP address you're given is this 172.14.0.0. We have to create the subnet in that range. So the first subnet, because they are all 0 for the borrow bits, that's going to be a 0 here, right? I'm going to highlight it in yellow so you can see the 0 here. And if you put this into your programmer calculator, you get a 0, and then the network address is going to be .0. This part is this 0, right? That's the third octet is the one highlighted in yellow. So that's the third octet is what we're going to manipulate. Then I know that the subnet 2 is going to use the second variation or the second combination of the 3 bits. So for the third octet, I'm going to change up the first 3 bits to 0, 0, 1. Right? And if you take this entire value for the third octet and you put it into your programmer calculator, you would get a 32 or decimal. Any questions so far? And then the last octet, because it's 0 for the network, right? IP, we'll keep it as 0 there. So in this step, what we want to do is we want to look at the variation in the borrow bits. And each of the variation would represent, right, your third octet value for the IP address, which is the beginning of each of the subnet. Then the third subnet, because this is the next one here, right? I'll highlight that in pink. So 010 is going to, and we take the whole entire value, convert it to decimal, and you should get 64. But when you're looking at this, you're going to see that it has an increase of 32 for each one, right? So if I look at the difference between the previous subnet to the next subnet, in this octet, that's 32. Now they have IP subnet calculator. Sometimes you can just put in the IP that you're using and it will crank it out. The only reason why we want to show you this is IP calculator is as good as its creator. So if it's erroneous, right, then that means that you're going to get wrong subnets. So you want to be able to check with your knowledge. And then the next variation is 011. So I put this into the third octet, I would get a 96. Hello. And then we continue to go with the next one here, which is the 100, right? We put that into your borrow bits, 100 here. That gives us 128. So once you put it in, you take this value and you plug it into your calculator, convert it from binary to decimal, and you would get the decimal value for your beginning IP range. And we would continue to do that for the subsequent variation for your mask bits. until the end. So when I plug in 101 here and take this entire thing and put it into the calculator, I would get a 160. And mathematically, if you see the increment, right, in each set, the difference from one set to the next is 32 in that octet. Now, this would be different for other IP and other cases, right? So you will have to go through step one and looking at the variation and then put in the variation for your host octet, right? So if you're using class A, that's different than class B or class C, okay? So keep in mind that it's always gonna lean in or borrow into the host octet. So if you're using class C, it only has one last octet on the fourth octet. So it's you're gonna manipulate that, okay? Any question? Okay, so once we have our combination for the borrow bits, we would set that into our octet that is the host octet, right? After the network octet. So we're going to put that in and we want to determine what that would be for each of the subnet by converting it from binary to decimal. So if you're looking at your first subnet, subnet 1, right? An assignable IP address would be 172.14.0 for subnet 1, right? This one. And the first assignable IP is going to be a .1 there, right? So that can be your router or your gateway. The next IP address in that range would be a .2. So you keep changing this, and eventually when you get to 254, right, then you're going to move into the next, the left octet. Now I can do that until I reach 31 because that's the end of the range for the third octet, okay? Because once it reaches 32, that's subnet 2. That's a different network. So for subnet 2, if you're looking at like an assignable IP address, look at subnet 2, right? I have 172.14.32. So you put that in and the last host octet, you change that to 1. That can be your router and the firewall can be a .2. And let's say a server can be .3 and so on until you reach 254. Then you get into the next one, right, which is 33, 33.1 and so on. Now the ending of that is going to be 63. So that's how you're able to get 8,100 so many hosts. Any questions? Okay. So the way that we use this table is so that you can see the transition from one subnet to the next. You don't have to use this technique. I only wanted to show you this so you can see. Okay, I'm gonna move to the next part. So for the next table, we are going to then look at what is going to be the usable IP address to start. We just talked about that, right? So for your first subnet, the start usable IP address, you simply change the last bit, the least significant bit to 1, and that's going to give you a .1 at the end. Right, so the first IP address in the subnet 1 is going to be 172.14.0.1. And subsequently, we would do the same thing for each of the other subnets. So you simply change the least significant bit for the fourth octet in this case to a .1. So, and typically you would see that these are going to be your gateway or your router for each of these subnets. So you would have, like, I would set that up for each of my router and be able to route into these subnetworks. And then if you want to use .2 for other systems, .3 and so on, like I said, we do not use .255 for the fourth octet for that broadcast, okay? So when it reached 254, then you would get into the third octet. And be able to use it. So I'm going to type an example here. I didn't do it for the Monday class, but maybe they'll watch the video. So when you reach the end of the fourth octet, such as 172.14.0.254, right? That's an example. Then what you would do next is you cannot use 255. So in order to get more IP, right, you can go up to 31 before it goes into the next network. So you can go, I don't know why I typed 127, but I'm sorry, 172. So 170, so you would continue in using the third octet, such as 172.14.1, right? .1, and so on, until 172.14.31.254. And that's how you're able to get 8,100, I think it's 54, right? IP addresses in each group, in each subnet. So it becomes less confusing when you look at the next table or the next few tables. Any question? So after we have our subnets and the beginning of our usable IP address, we want to determine the end usable, right? Because it's a group, we want to determine the ending usable IP address, and that's the next table. So as I mentioned, right, you would use up all your binary values here in the octet. And then what you do is you're going to move into the third octet. So in this case, the N, right? We keep the third octet, the third borrow bits, the 3 borrow bits the same. Okay. So 00001, you saw that at the beginning. And what you do is it's going to fill it up with the ones at the end. And if you convert them, you are going to get 31, 63, 95, and 127. It is one less than what you see in the previous table for the third octet. So the end of the subnet 1 is one less than the beginning of subnet 2. Understand? So because makes sense, right? You reach the end of the first network before it can get to the next network. So this 31 here is one less, and that's the end of the subnet 1 before it gets to the subnet 2. It's one less than subnet 2 for that octet. And the last usable host for your fourth octet is always going to be 254. You cannot use 255 because that's a broadcast. So if you take this value and convert it each time, you should be able to yield this, right? 31, 63, 95, and so on. And which is one less than what you see in the last table for the third octet. Because it is the end of the prior network. Is that clear? Do you have any questions? And the variation of bits that we talked about in the earlier part of the exercise, right? They stay the same. The main changes for the ending assignable IP address is that these 5 ones in the back, they get filled in, right? They receive signal to fill in all the 5 ones. The first 3 stays the same. And then for the fourth octet, right? It's because it's the end, which is 254, your least significant bit is remaining 0. And all the other bits in front of it is 1. Any questions? So in networking, this is probably the hardest part for many administrators and people that start out. I would encourage you to practice, and I think I will talk about the extra credit when you can do your practice in the workbook a little bit more. And then once you have that, you can submit it and I will give you some extra credit points. It is not something that if you do it one time, you might grasp it, but the more you do it, it gets easier and you can quickly see it too, on how the pattern for specific subnet mask would be. And it is easy. There are a lot of tutorials on how to do subnetting with IP address, and people use different technique, and traditionally, this is a way that I want to represent it so you can see it from the binary. And when you convert it, it exactly is right. So you can check your work. Any question? So we started out with determining the subnet that we need so that when we can see the mask bit, then we'll be able to use that CIDR to be able to calculate the number of hosts. Then we would go through and determine how the variation of your borrow bits, so that way it would represent the decimal value in your octet for the host bits. And then we would determine the range of usable IP address, the start and the end of it, so that way you can create a list on how you want to assign that to each individual system that's connected in your network. Okay, any question? So in the future, if it's convenient for you, right, you should use a calculator to be able to do this quickly. But you should check your result and determine if that's correct before you input that into the configuration of your system. So for example, you saw how we create scope for DHCP, right? This is before the DHCP part is when we would be able to determine, right, what is the range of IP address that we want to give out to the systems that are connecting. So once you have this, then you can put that into, create a scope and be able to put that into your server, and your server would then assign to any connected system that is asking for IP address. Simple. Now you will see later that your server, right, the way we look at Windows Server, it doesn't have to be a Windows Server to do DHCP. At home, you already have the router to do that, right? And they created the home router for your wireless network to have that capability with the default range. And you can modify your range also, right? You can create subnets within your home network to scale out, but you are limited to 100 and something systems. So, you know, because it's a class C that you're using, but also your router can only handle that much. Technically, you can get up to 200 and something systems IP, but your router would only handle that much traffic. Okay, so now, next table. So once we get this column, right? And this column set up, the main changes between this table and the next table is that the last octet, your fourth octet, is going to become 255. That's going to be your broadcast here, and they are all ones in the fourth octet. So your broadcast address for each of your subnet will be the ending address with the fourth octet plus 1. So the least significant bit, the last bit right here becomes the 1, right? Which gives you the 255. So once you have the ending IP address, you would have the plus 1 to the last octet to get your broadcast IP. So I'll put that as a note. Nope. Right? Use the last IP in the range, then plus 1. So the usable IP address, mostly we would work with the fourth octet and sometimes the prior octet, depending on the class. But in this case, right, the third and the fourth octet for each range. Now, if you're using class A, then you would also have the second octet because that's also your host. And class A is going to give you more IP addresses that way. So if, let's say you function as a network engineer and you need to design subnets, right? And be able to determine like how many systems for per subnet and be able to set up the scope for each one. And also configure your system with specific CIDR using the subnets. You need to have the summarized table like this. Okay, so once we have everything calculated out, we will put it all together in a summary and it will be this kind of table. So you have subnet 1, right? Your network address is always a .0 at the end. The first usable, you pull that from the prior table and you put a .1 here. And the last usable IP address, notice that the 31.254, right? Your broadcast address came from the last table, 255. And so the new subnet mask that you are using is going to be 224. Why? Because if you look at the binary value that we converted for the subnet mask in the prior set, this is 224, right? As a decimal, when you plug that into your programmer calculator, or the CIDR 19 So 8 + 8 + 3, that's gonna give you /19. So I'm gonna show you. So I have my programmer calculator here. And if I put in the binary 111 and the rest are 0, because we're borrowing the first 3 bits for our subnet mask, right? And if you click decimal, you get 224. So that's why it's 224 here to represent, right? This subnet mask represents the CIDR 19. 19 bits are on for that. So the appliances, the network appliances, they're pretty simple. They're just looking for signal that's on and off. So that means that 19 of the byte, I'm sorry, the 32 bits, 19 of the 32 bits receive signal. Okay, and the rest are off. So that's how it's able to know, oh, that's the area of the network. And for each of the network, we know that it is 8,190 because we did the calculation at the beginning. So combine, you take 8,190 times 8, you have quite a few systems, right? Using a class B originally and subnet that out to 8 subnetworks. And in this case, we would now have, right, 8 additional routers that's going to route traffic to specific area. And this could be branches in your company, right? Or departments that you want segregated within your network. You know, or different areas that you want to be able to have separation for privacy and data protection purposes. So it can be implemented for VLANs as well. So I can use, let's say, 4 of the subnets as regular, you know, network, part of the network infrastructure. And then the last 4, I can use it for VLANs. So I can configure my switches to be able to route that way for, and it's still on the same rack, right? In the same data center or the server room that you see. But we can create scopes for our DHCP for the VLANs and the regular network. So this is critical, right? Like once you get this, you know, designing network and setting up IP addresses and using topology is a lot. It's seamless, right? So it's important that you understand this. Now, from a security perspective, you might not be designing network and things like that, but you will work with the systems that is part of specific scope, and you have to be able to identify like what part of the network is that coming from. Like if you're getting attacked in subnet 5, right, you have to know that that's subnet 5. Okay, because you might not have the topology or the engineer there to answer that question. So on your notes, I have all the documented steps on how you can go about from the start throughout, and you can look at that example as well. Like I said, there is an extra credit assignment that you can use to be able to practice and get better. And if you're not clear, right, you can see me outside of class if you need to, or ask questions now. It's okay, I can go over some of the concept as well. So to be honest with you, when I first learned the subnet, right, it took me a little bit of time to kind of understand the actual process and the concept. And when I put the assignment together, I asked myself, like, how do I want to visually display this and progress in the assignment so that way the students can see like how it's applied, right? There are different techniques on how people subnet. And if that works for you, you can also use other techniques. So at the beginning, we talked about the 2 minus the 2, right? That's 1. And the other one is a .0. That's what you don't use to assign. But there are systems that use the IP address to specifically to send to all, right? When it's not like, let's say the switch doesn't have the MAC address or whatever, or MAC IP information record on the ARC table, right? It would use a .255 to be able to see who's who. The router uses the .0 to really narrow down like which subnet are we referring to based on the IP address for the .0, the network address. Okay, let's move forward to the next exercise, which is number 3. Given the below IP addresses and the subnet mask, determine whether each option is a classful or a classless address. What you just did right now is you take a classful address and you convert it into a classless address. So originally we might have a class B address in the exercise and we use the mask bit to make it classless. That means that it no longer becomes a default class B address. It is now using the subnet mask that is leaning into a class C, right? So it becomes classless. So let's look at 3A. If you have 10.0.0.30, this is a usable IP address, and the subnet mask is a default classful subnet mask. 255.0.0.0. This is a class A subnet mask. So it is a class A, so it is classful. It belongs to class A. Okay. Pretty easy. So the next part of the notes, it talks about that. What's the difference between classful and classless? Classful is when you are having a subnet mask that is using mask bit or custom subnet mask, right? Like a different CIDR than your regular class. Based on what we were given originally. Then the next one, 3B, 141.18.0.19, right? And it uses 255.255.248. This should be a giveaway, right? If it's not 255 here, then this is a classless address, right? So classless. Because it should be using class C, where it should be 255 here, but it's not. So it's 248 here. Then it's a classless address. Same thing with C, 204.110.0.193, usable IP address. But you see here that it is not 255. So it has mask bits, right? So it's a class. So sometimes you would see that it is a classful where it's 255 here, but it's not. So it's 192 here. So it's a classless address. And then we have D, 48.255.255.254. And you can use it this way. It just cannot be in the host, the last octet. Okay. So, and your subnet mask is 255.0.0.0. This is a default class A subnet mask, and that represents that in the first octet, right? It is 1 through 127. So what you 126. So what you see is the 48 here belongs to class A, And this is a class A subnet mask, so it is a class 4 address. So when you look at this, you look at the octet in the front, right? And you look at the subnet mask to see if it's correlate to that class. If it's not, then it's a classless address. So looking at the class table for class A, B, and C is useful to know that tables. So you will have similar questions to this, like this on quiz and exam, and also your certification. Any question? Okay, I will maybe move 3 down. So for those of you who's still working on 3, and then let's move this up a little bit. So now I want you to practice a little bit with using CIDR, right? So that is just the way that we would represent the bits for the mask with a slash. Okay, so for A, 10.0.0.30, the same IP address you see for number 3. Your subnet mask is 255.0.0.0. So you look at the 255.0.0.0. 255 represents all 8 bits are on, so it's 8. And then the rest are 0, so plus 0, plus 0, plus 0. I have a CIDR 8/8. Then we would calculate for B a little bit. So we would look at the subnet mask. 255 is 8 bits. The second 255 is another 8 bits. And if you want to know the 248, take your programmer calculator, clear, right? Hit decimal and put 248 and look at the binary. How many bits are ones, right? Count them up. So I have 1, 2, 3, 4, 5. So 5 bits that are ones. And so that means it's going to do a +5 for the 248. So the 5 here represents the 5 ones that are on in that binary value that will be equal to 248. And so when we total that up together, 8 plus 8, 8 for the front, 8 for the next octet, and the 5 for the 248, we have a /21 or a CIDR 21. And then for question 4C, you have the subnet mask 255.255.192.0. The 255 each has 8 bits, so 8 plus 8. And then just like what you've done in the previous step, so the 192, take your programmer calculator, hit decimal, type in 192. And then click bin for binary and count up the bits that have the ones. So in this case, I have 2. So 8 plus 8 plus 2. And the last one is a 0 here. So plus 0, I have a /18 or CIDR 18. And then the last step, 48.255.255.254, its subnet mask is 255.0.0.0. So 255 gives me 8 bits or 8 ones, right? That are on, 8 bits are on, so 8 plus the rest are 0. I have a CIDR 8, similar to what you see with 4A. So the takeaway from this is you take the subnet mask, you look at how many bits that are on in that subnet mask, the total of bits that are on is going to be your CIDR. All right, each octet at a time. So I wrote it out so it's easy for you to see. Any question regarding cider? So some system, it doesn't require you to type in the subnet mask with as a full, right? 255.0.0.0. It would request or prompt you to type in a cider. So you just need to make sure you know how to be able to take your subnet mask and then convert it to a cider. And then you can put that into the configuration. Now, some system will take both, right? You can have an IP address and then you put /18 and it would know that that's the subnet mask using the cider. Okay. Now we're gonna switch gear a little bit. We're gonna talk a little bit about algorithm. Give me a second. Let me get to for routing. So the second part of this after cider that will begin on page 5 of your notes. It talks about static and dynamic routing. Today in your packet tracer, you don't have to do so much of this, but in the future lab, you will set up your routes. So static routing is a way that we can have a specific path that is we sending the traffic from point A to point B. It's like how you drive from home to work every day the same way, even though, right, Google Map or your map system gives you alternate ways to go from home to work. It is how we want the network to pass the traffic in the same way over and over again. Then you would manually put in, like, for example, router A to router B to router C, to be able to get to router D. And it's exactly the same way. So in some cases, you want, like, for example, safety with information that's passed, and how we would get it into the public network, you can static route. But in dynamic route, what we can do is we can utilize the protocols in the router to be able to update each of the router on how it passed. So for example, you're driving along and you're going from home to work and there's an accident, right? Your map system tells you, oh, there's an alternate way for you to get there and it would save you a few minutes. So what the router does is it would be able to update itself, right? By adding in different routes for the system. Sometimes it's also talking to the neighbor to be able to determine if other routers are available. It's kind of like you're checking to see if there are adjacent streets that's going to be open so you can detour, right? So dynamic route really is a way that we make the internet because your routers across your service provider are autonomous systems. They figure out how to get your traffic from, your home to YouTube or your gaming server quickly, right? And there are different type of services and protocol that's used. So in your lab today, you are going to type in your RIP version 2, right? That is a routing information protocol, and currently we're using 2 or newer. So RIP is an older protocol that's used in router. Now, later on in the notes, it talks about that, or some router would use open shortest path first. So it calculates, right? Like from here to the next router, what's the fastest way to get there? And it's able to pass that way. So what it does is it has a value that it used to measure to calculate that vector. In my discrete structure class, we talked about map and be able to go from one node to the next, and it is the same concept. When they created this system, they programmed them to be able to do a measurement. So open shortest path first is then calculate, right? Like, think of it like the total number of miles that you're gonna go across these streets or freeway to be able to get from home to work. So it talks about distance vector algorithm here, right? So what it does is the first router, it's going to then look at the neighbors, the adjacent routers, and it's going to calculate the cost based on how it's able to pass it. Some of the time, right, it would be able to look at time and distance, hence the name distance vector, kind of like the number of miles that you go from one street to the next street, right? So it's going to go from one node to the next, looking at the distance weight. And those are numerical values that they implement. And it would compare. So if I go like from here to like maybe Alessandro, right? The next street, this is the number of miles that I need. But if I go from here to, let's say, Nason, this is the number of miles that I need to pass that street. So it is a process to compare and measure the weight. Then it also looked at link state. So link state is basically looking at how it will be able to map based on, or the shortest path algorithm, but it's looking at how the systems are connecting in the state, whether it's listening, right? Whether it's busy, passing, or it's ignoring, okay? So let's go through and answer some of these questions. Number 5, identify the type of routing algorithm for the scenarios. A, the node sent information from point A to point B via the path and the results. That would be the lowest cost, right? So it total up, it sums up the value and it does the comparisons, and that could be the cost for the distance. So that will be your distance vector algorithm. Likely that your certification will ask these type of questions. You also see them on quiz and exam. So to produce its map, each node floods the entire network information about other nodes so that way it can connect. So it actually checks, right? Kind of like how you would be able to look at like all the other streets, how busy are they, right? So it looks at the link state. Are the systems listening? Are all the systems listening? All the neighbors? Or are they busy, right? Are there traffic on all the other streets that's nearby you, right? So link state algorithm. And then for C, each border router advertises the destination that it can reach to its neighbor router because it has a table that's stored, right? So it's gonna say, this is how I can get from point A to point B. And the other one does the same thing. This is how I can get point A to point B. So the router that's gonna be making that decision, it's gonna look at, right, all the advertised path, and it's gonna determine what would be the best path to take. It's kind of like you're looking at 5 different ways to get from home to work, and you would decide that maybe based on time, or maybe based on distance, or maybe based on, so ultimately it looks at what the other routers can handle to be able to pass it. Okay. Now, not all routers are capable of doing all of them, right? Some routers are made for specific service, so they have specific protocol. My recommendation is when you're working with routers, just make sure you check its specification, right? The type of protocols that it's able to handle. And that's how you're going to be able to set up your dynamic routes. So dynamic routes ultimately implemented different algorithms and be able to update the table so that way it can always refer to that. So if I know that there's a way that I can get from home to work quickly, I might be able to use that next time, right? When I'm in a pinch. Or sometimes people drive and they go the extra distance because they want to, you know, they want the scenery or they wanted to look at things or whatever, right? So there are reasons in these things. So we really designed the algorithm that really represents how we would use these systems. So it does have some human factor that's involved, as you can see. That kind of wraps it up, but I would encourage you to go through the notes, right? Read it. You can also research it. So it talks about optimized link state, path vector protocol, loopback interfaces. So you see more of this when we do the routing lab, where you would configure the router, the physical router, and then you would be able to see. Now, like I said, different models support different type of service. So if you're using one model and maybe the next number, right, like the 5051 might not have the same algorithm. So you just make sure that you check the actual spec. Okay. Now it goes into things like loopback interface, where it would in order for the adapter to see and send information, it does see itself, right? Just like your computer. And then for the loops, this is a common problem. So when you have loops in network, right, when it has the error, so it keeps circulating that, it keeps trying to find the node to be able to pass it, but unable to do that. So that will deplete your bandwidth. Typically, you can access routing table by using the route command for most of the appliances. And then it always would have a default route. That's kind of like your go-to way to get from home to work, no matter what happens. You know that you will get there. And so we would set a default route. And so that can be in the configuration. You know that router uses IP address only, right? So you would be able to set. So I can go from one subnet to the next subnet by setting up my route, point A to point B, right? So all the subnets that we went over needs routers to go from one subnet to the next. Okay, so in the lab today, you would see the terminology MTU. So that will be your maximum transmission unit. Basically, it is the measurement of what is the most that it can handle as far as data. Okay, because the larger the data, right, the slower it can be. So that will be the maximum data unit that it will be able to pass as a packet. You can also use built-in routers for routing data inside your Windows OS. And there is a way that you can use route print. You can add a route in Windows environment by doing add route or delete route. So you can modify, like if I want to do a static route, I can do an add route command, but make sure that you look at your route table first, okay? And so there are also additional router protocols. Now, I know in security class, they talk about interior gateway protocols and other form of protocols as well. But a lot of the times you see these are implemented for autonomous system. We talked about RIP, which is what you see today. It uses distance vector, so it calculates the cost, okay? Now, the newer router might not support RIP because RIP is more of like an older protocol. So in order to access it in Cisco appliances, you can do router RIP, right? And it would also specify, so that way it tells you like which version you're using. Don't use version 1 anymore because it's vulnerable and that can create security problem on your network. So you should use version 2 or newer if they use that. And if you use IPv6, you would set up the route for IPv6. So it does use the same as distance vector. And then I talked about open shortest path first. This is very common. So it looks at like who's available and how fast can it get there, right? So it's slightly different and so it's going to be able to determine that. And it supports version IPv4 and IPv6. So you do see some of these protocol that falls under distance vector. A lot of them are, okay? And the latest version, I think we talked about this before, for interior gateway, you have enhanced interior gateway. This is more of a later implementation. And it advertises the routes to other router. And I like to call it the nosy neighbor. So it looks at the other routers and it advertises it, right? And it only sends updates incrementally, so it doesn't take up a lot of the bandwidth to do the updates as it transmit. And if you're using an exterior gateway, you have to use a different type of service for your routing. So you do see more of this if you are looking at service provider networks like your Spectrum, Frontier, but in the case if you're working with data center or larger networks, enterprises, you see a lot of these. Question? So the hard part about Network Plus is the terminology, right? Lots of protocols and things to remember, but try to read it and try to understand which one of them, which does what. Last thing I kind of want to talk about before we end is each router usually have metrics. So think of it like a table that it uses to update the values, the cost value, and it uses this to be able to compare. And so if it's able to see that, cost value is lower, then it's going to decide on that path. And it talks about different. So in this class, we don't usually have to calculate this, but I want to refer you to on how you'll be able to calculate. So for administrators and engineers, right, they would have to determine like the load of their data and how you're able to predict your bandwidth. Some of the systems now, if you buy more of the more expensive system, it has this calculation and the comparison for you for analysis. But if you become a network analyst, you also have to work with this to determine how you can improve performance if there is a certain amount of load, right? Like let's say that 8 to 12 in the morning, 8 in the morning until noon, you just have heavy load because you might be online retailers and that's when your customer shops, right? And so you want to be able to look at how your systems are linking and if there's delay because there's tremendous amount, or if you're running a game server company or a streaming server company, you do have to deal with load because you might have like from 5 to 8 p.m. a lot of people are on streaming and be able to handle that. Okay, so it talks about on how you can be able to calculate the bandwidth and looking at the metric and so terminology wise, hop is each of your router or your nodes, and then what the load could also mean, right? So in security, we care about reliability because that's going to give us availability, right? So if your network is on at the 7 nines now, 99.999%, then that is ideal. But a lot of times we might be under because, there are things that impact us. So you want to make sure that you have some kind of performance analysis throughout the year. And that's going to help you improve on how you can, expand your network or implement new appliances. And sometimes when you implement security system, that can also slow down because you're filtering a lot or you're checking a lot, you're monitoring a lot. So we want to look at solutions that's going to be giving us reliability, security, but yet at the same time doesn't floor our performance, right? Because a lot of my upper class students, when I taught the upper classes, they always tell me, oh, just add a firewall, add more firewall, add IDS, add IPS. But you have to know that those systems, right, it interrogate the traffic. So the traffic has to pass through them. And if you funnel and you, just like how, if they have like checkpoints on the holidays, right? Everybody has to slow down and the police can check their car or their driver license. That becomes more of like a slowdown in your bandwidth. So you don't want too much filtering, but you want enough so that way it has a security measure, okay? All right, so I will stop now and give you a break.